Hi, I'm Steve. I'm a technical sound designer, and musician from the Chicago area. Welcome to my demo reel, where I'd like to show you a few systems that I put together for some projects that I've worked on. For this project, I implemented the footsteps using custom Notify blueprints that were placed on the character animation. There's one Notify that handles the footstep impact sounds, and another one that handles armor rattle and clothing sounds. The footstep Notify blueprint itself looks like this. When the Notify is received, a line trace is done to the surface directly beneath the character to get the physical material surface type, which will determine which footstep surface sound to play. If the surface is water, an additional check is made on the length of the line trace to determine the depth of the water. If the water is shallow, an additional splash sound is played for the sound of the foot hitting and entering the water. The Metasounds themselves are organized in a data table, which allows them to be easily added or changed without going into the code. And each footstep Metasound is derived from a one-shot base Metasound that I made that will allow you to randomly choose from an array of footstep variations and then add random pitch shift before playing. For this project, I wanted to sync as much of the game as I could with the music, and I was able to do this with the help of a quartz clock. The scaling of the platforms in the level, the enemy movements, aiming and firing, and even the fire rate of the player ship's gun are all done in sync with the music. A single quartz clock is created and set to the BPM of the song, and any other actor in the game that needs to be synced to it can subscribe to its quantization events. For example, the enemy turret will turn towards the player on the first and third beat of every bar, and it will shoot on the second and fourth. There's also a bouncing scaling effect that happens with the turret that happens every eighth note. For the music, the main loops of the song are triggered from Blueprint through trigger inputs on the Metasound, which are triggered to play again every bar. There's also a lead synth instrument that's triggered every quarter note, and tries to play a note from a selected scale based on probability, and a selected seed to ensure note order and repeatability. The spawn composition and enemy spawn timing is then taken care of by this function, which subscribes to the level clock and keeps track of the bar that the song is on. Then you can simply choose which measures you want to change the instrumentation of the music at, and use this node to set which instruments you want to turn up or down. There are also nodes to spawn enemies just off screen. The music system for this project plays a different piece of music for each of the areas in a level. This level contains 3 different areas. Here, out in space, on the space station, and then in the cargo hold area, off in the distance. The switching between music is handled by a music component that's attached to the player controller. The music component creates a quartz clock and subscribes to the beat quantization event, which will help with stopping and switching between songs. Each song has a pair of events to handle playing and stopping the music. The play event will stop other music, set the BPM of the quartz clock to the new music, and start the new music quantized to the first beat of the next measure. The stop event sets a boolean that indicates to the system that the music should be stopped. If any of the stop booleans are marked true, a quantization event that checks on every beat will execute the stop trigger parameter and the corresponding metasound on the next beat. The metasound for the song that plays while you're flying your ship around in space is fairly simple. It plays an intro where the song builds and then goes into a loop until the stop parameter is triggered. This stops the loop and then plays the ending. The music that plays on the space station features 2 instruments that procedurally play their parts based on some set parameters. Every quarter note, each instrument will try and play a note based on a set probability. Then, if it does decide to play a note, one is chosen at random from a selected scale, and then played with a sign generator. Then, add effects to taste. The seed value is used to ensure consistency and repeatability. In this song, every 32 bars, the seed values are swapped. This gives the song some variety while also giving it some structure, giving it an A and B part to switch between. The meta sound for the last song is slightly more complicated, but it incorporates some of the same elements as the other two songs. The washy synth that acts as the bed of the song is wave-based. It has an intro, a loop, and a tail. Every 16 measures, a system of trigger compares and accumulators will stop the loop portion and play the tail portion, while also muting the kick drum, and then playing the loop portion again when the tail is finished. An upright bass sample and a kick drum sample are played using a fusion sampler, and are composed and controlled using the same MIDI step sequence player. The strings work similarly, but are composed using their own step sequence player. The snare and hi-hat are created with filtered white noise, and are controlled with audio envelopes that are triggered every other beat and every eighth note respectively. Lastly, the pluggy lead synth instrument is an oscillator that plays procedurally generated notes similar to the instruments in the previous song. This project contains a series of programmable step sequencers that each control a different instrument. The sequencers can be programmed using buttons laid out in a grid representing beats and notes that can be turned on and off to play the desired notes at the desired time. Each instrument also has a corresponding visual effect that happens when a note is played. And then for the drums, each part of the drum set has its own effect. Each instrument has a corresponding step sequence asset that's programmed using the buttons on the sequencers in the level. Then the logic for each instrument's step sequence is contained in a meta sound that's placed in the level. For the guitar and drums, the step sequencer controls a fusion sampler that's loaded with a custom patch that contains samples of the instruments. For the two synth instruments, the step sequencer triggers an envelope and controls the frequency of a wave generator in a separate meta sound. Each instrument's audio is sent to its own audio bus via audio bus writer. The audio buses are then read from in a separate meta sound, which each send their audio out to their own submix. The submix's envelope followers can then be subscribed to control the VU meters in the level. And lastly, back in the music meta sound, MIDI on and off note events are output via trigger parameter outputs for each instrument, and in the case of the drums, for each piece of the drum kit. The outputs from the meta sound are subscribed to by the Music Manager blueprint, and each have a corresponding event that will play a visual effect within a set bounds in the level. Thanks for taking the time to check out my demo reel. Once again, my name's Steve, and if you like what you've seen, you can find more of my work or my contact info at the links below. I look forward to hearing from you.